state of a thermodynamic. Yeah, thermodynamic state. How it is defined? State means the condition of a system described by its properties, right? Its properties like temperature, pressure, density, enthalpy, entropy, right? All these are the properties of a system, right? Here in a PV diagram, if we see, so at a state x then y, x comma y, in this form we represent any point in a x comma y, right? So here x is volume and y is a pressure, right? Y axis process, right? So process is a change from one equilibrium state to the another equilibrium state. It called process, right? For example, here state 1, here this is state 2, right? State 1, here as we know this is PV diagram, right? State 1, here this is the higher pressure, right? Then the state 2 will reach at a state 2, right? Equilibrium state 2, right? This is state 1 and this is state 2, right? So this is called a process, right? From one equilibrium state to the another equilibrium state, right? The path of the process, right? So path of the process is the series of the states that the system passes through during the process, right? So here state 1, equilibrium state 1 to the equilibrium state 2, right? This system passes the number of equilibrium states, right? 1, 2, 3, 4, 5, 6, number of states, right? So when we connect these processes, so this is called process path, right? Next type of processes, right? There are number of types of processes, right? For example, here it's a number 1, it's isothermal process, right? Isothermal, as its name indicates, iso means same, thermal means temperature, right? Isothermal, temperature is same, right? As we know, equation of state PV equals to RT, right? When temperature is same, so PV equals to constant. So when we draw in a PV diagram, PV equals to constant, so it will in a PV diagram, so it will come, this curve will come like this, right? So here this is a constant temperature line, right? Or this is also called isothermal process, isothermal process, right? Here 1 to 2, this is a isothermal process because the temperature during this process is constant, right? Next one is the isobaric process. Isobaric, as its name indicate, bar we are generally measure pressure, right? So iso means same, bar it's a pressure, right? In a PV diagram, pressure is constant, so process will like this is a constant pressure here for state 1, for this is here it is state 1, this is state 2, right? So this is the constant pressure. So this process is called isobaric process, right? Next is the isochoric. Isochoric means volume is constant, right? In a PV diagram, if I draw PV diagram, so isochoric means volume is constant. So here state 1 to 2, this process is called isochoric process, right? Adiabatic process means PV to the power gamma equals to constant. When we draw this is in a PV diagram, so it will come like this. There is no heat interaction between system and surrounding, right? Work will interact, but no heat interact between system and surrounding, right? Next is the cyclic process, right? Cyclic process, right? In a thermodynamic cycle, or we can say in a thermodynamic cycle also, right? So this is the processes in which system returns its initial state is called thermodynamic cycle or cyclic process, right? So here initial state or final state, right, are identical, right? Initial and final state are identical. For example, here in a PV diagram, right, here we are initially at state 1, right? We move state 2 and then move process through the process 2 to 3, we reach at a state 3rd, then process 3 to 4, we reach at a state 4, then again 4 to 1, we reach at a state 1. So final is we reach at a final and initial are the same, right? So this is the cyclic process, right? So similarly here this is also a cyclic process. We reach from state 1 to 2, right? Then process 2 to 3, and then again 3 to we reach at a initial state at 1. So this is also a cyclic process, right? Here PV diagram, here in a diagram 3rd, here this is also a cyclic process. We reach 1 to 2 process here, and then again we reach through this process at a state 1, right? We reach at a state 1. So this is also a cyclic process, because initial and final all are the same, means in a here also, in this diagram also, and in this diagram also, right? Next is the reversible and irreversible process, right? Reversible, or this is also called quasi static process, right? It will be almost static, right? When we reach here state 1, then we reach here, for example this is A, B, C, D, E, F, right, up here to state 2, right? So 1 to A, then equilibrium state A to B, B to C, C to reversible process. We reverse the process, the system and surrounding will restore its initial state, right? Both system and surrounding, right? When we reverse, for example this is a process A to B, when we reverse it, so we will restore the system and surrounding will restore its initial state, right, of a system, right? What are the properties, right? Properties are used to describe a state or the condition of a system, right? State or condition. Condition means how much pressure, means how much pressure is there, what is the temperature inside within this system, right? So, right, intensive properties, the properties, intensive properties means the properties which are independent on mass, right, of the system. Such properties are called intensive property. For example, temperature. If I am giving one example here, it's a we have a container which have water, right, here, which is filled with water, right. So when we take 1 cup of water here and we measure its temperature, right. So its temperature, for example, it's a 37 degree centigrade, right. When we measure the temperature of this whole container, water of this container, so this will also give the 37 degree centigrade, means here is a less mass but here it is a higher mass, right. So it means the temperature is a intensive property, means it's a independent of mass, right. Right, temperature and density also. Density of 1 cup of this is water, right. So this is the density of water at a, right. So it will generally we take 1000 kg per meter cube, right. And a property, right, extensive properties which are depend on mass of the system are called extensive property. For example, here number 1 is the mass itself a extensive property, right. Number 2, it's a internal energy, right. So higher mass, right, so definitely higher internal energy of the system. Similarly, enthalpy also and entropy also a extensive property, right. Here one note is there, all extensive properties per unit mass are intensive properties, right, such as specific enthalpy, right, specific internal energy, specific entropy, right, entropy, all are the intensive properties, right.